Hey guys, I hope you're doing well. So, as promised, I have made a pretty paper for paper two. It's going to be the calculator one for AQA Level 2 further maths. I've included all of the topics that did not come in paper one. Some of the topics are sometimes repeated in paper one and paper two, but the difficulty level of questions changes. So, based on that, you will see some topics being repeated. If you think I've missed out any topic that did not come in paper one and that is not in paper two, please let me know in the comments below and I'll try to make a separate video for that topic before the exam. If you're someone new to the channel, I would recommend watching the predicted paper for paper one because the topics that did not come in paper one but are included in the predicted paper video, I'm going to highlight those topics at the end of the video. And if you want to practice those topics as well, I would recommend going to that video. I would recommend checking that video out and looking at those questions from that. I'm going to share the link of that video in the description below. And if you're someone who's new to the channel and if you like and understand the content of this video and how I formulated this paper, please subscribe and like the video and share your thoughts in the comments below. So without further delay, let's start with the questions. So I was told that multiplication of matrices came. But just to be on the safe side, I added two parts to this matrices question. One is for multiplication and the other is for transformations. And for the multiplication one, I chose a difficult question which uses algebra as well to figure out the values of a and b. So to be on the safe side, it's best to practice it just in case they give it again. So we have 7a squared b negative 5 being multiplied to 2a, and the result is 78 and 12. We have to work out the values of a and b. So as you know, when you're multiplying matrices, it's row times column, then again row times column. So first we'll multiply 7a squared with 2na. So it's going to be 7 times 2 plus a squared times a. And then it's going to be b times 2 plus negative 5 times a. And this equals to 78 and 12. So that gives us 14 plus a cube and 2b negative 5a over here, which equals to 78 and 12. So we put 14 plus a cube equal to 78. So that's a cube equal to 78 minus 14, which is 64. Cube root both sides. So a is 4. Then for b, 2b minus 5a equals to 12. A is 4, so 5 times 4 equals to 12. 2b equals to 12 plus 20. That's 32. B equals to 16. That's a value of a and b. Then next we have matrix A, and they want us to describe geometrically the single transformation represented by A. So whenever our 1 is negative over here, that means the matrix was reflected in the x-axis. I'll give you a rough overview for all of them. So if it's a reflection over the y-axis, in that case, this one is negative and everything else is the same. We're reflecting the identity matrix. By the way, identity matrix, as you know, is 1, 0, 0, 1. Then if it's a reflection over y equals to x, then it's the same. Then it becomes 0, 1, 1, 0. You swap them. And if it's a reflection over y equals to negative x, then it's 0, negative 1, and negative 1, 0. So these are the reflections that you can get for transformations. Then it says B is 0, 1, negative 1, 0. Describe geometrically the single transformation represented by B square. So for this, let's find B square first. B square is going to be this matrix multiplied to itself. So that's going to be 0 times 0 plus 1 times negative 1, then 0 plus 0, then negative 1 times 0 is 0, plus negative 1 times 0 is 0, then negative 1 times 1, negative 1, plus 0. So that gives us negative 1 and 0 over here, and 0 over here, negative 1 over here. This represents the rotation of 180 degrees about the origin. For other forms of rotation, if we have a rotation of 90 degrees, then the matrix is going to look like 0, negative 1, 1, 0. Then if we have a rotation of, and this is clockwise. If it's anti-clockwise, then it's going to be 0, negative 1, 1, 0. Then if it's a rotation of 180 degrees, this is it, negative 1, 0, 0, negative 1. If it's a rotation of 270, that's 0, negative 1, 1, 0. This is clockwise. And for anti-clockwise, for 270 degrees, that's going to be 0, negative 1, 1, 0. So if you notice, clockwise 90 degrees, anti-clockwise 270 is the same, and anti-clockwise 90 and clockwise 270 is the same. So you can remember through that. And for rotation of 180 degrees about the origin, it's negative 1, 0, 0, negative 1. So as far as I know, inequalities did not come in paper 1, so it's bound to come in paper 2. So for this, it says that circle the solution of negative 3x less than negative 18. So whenever we have a negative sign on both sides of the inequality, to find the value of x, we will flip the inequality when we divide both sides by negative 3. And what we get is x is greater than 6, not less than. So this is your answer. And it says circle the solution of x squared greater than equal to 16. So we will take the square root on both sides. So we get plus minus 4. So negative 4 is over here, positive 4 is over here. So since it's greater than equal to plus minus 4, that means we're looking at the values above the x-axis. So above the x-axis, at x equals to negative 4, the values are decreasing. And at x equals to 4, the values are increasing. So this is your solution. X is less than equal to negative 4 because the values are decreasing, and x is greater than equal to 4 because the values are increasing. Then it says 3n squared minus 2 is less than 34. Work out the possible integer values of n. So for the integer values of n, what we do is we take the 2 to the other side. So 34 plus 2, that's 36. Divide both sides by 3. N squared is less than 12. Take the square root on both sides. So that gives us n is less than plus minus 3.87. So negative 3.87 comes over here. Positive 3.87 comes over here. So since it's less than, we look at the values underneath the x-axis. So underneath, negative 3.87 is increasing and positive 3.7 is decreasing. So since they're converging, so that means the integer values that satisfy this inequality are going to be negative 3, because negative 3 is greater than negative 3.87, then negative 2, negative 1, 0, 1, 2, and 3. These are your integer values of n, which satisfy this inequality. Then simultaneous equations did not directly come. Like I heard, like a question came where either a circle was intersecting with a line or like a curve was intersecting with a line, something like that. So what can happen is that they can give you a set of simultaneous equation like this, or they can give you the 3 simultaneous equation. So to understand the 3 equation simultaneous equation question, I would recommend looking at the predicted paper 1 video, which is attached in the description. I've given a detailed description of that in that video. And for this is the second type. So this way you can look at both types of the question in case either of these come in the paper. So we have 3x plus 4y equals to k, and we have y equals to 2kx. Solve the simultaneous equations. So since y is equal to 2kx and they want the answer in this simplest form in terms of k, which means we don't need to get rid of k. The answer will be in terms of k. So let's begin with substituting y equals to 2kx into the first equation. So I'm going to replace y with 2kx. So that's 3x plus 8kx equals to k. I will take x common because we want to find the value of x and y. That is the solution. So it's going to be 3 plus 8k inside the bracket. And x is going to be k over 3 plus 8k. Now since y is 2kx, so just replace the x with k over 3 plus 8k, and that gives us 2k square over 3 plus 8k as the value of y. So that is the solution to this set of simultaneous equations. X is k over 3 plus 8k and y is 2k square over 3 plus 8k. Once again, if you want to go through this 3 equation simultaneous equation, please check out the video that I made for paper 1 prediction, which is in the description below. Then differentiation. So I heard that like very little differentiation came, like not a lot. So which means like more differentiation will come in this one. So we have a curve which has an equation of y equals to x cubed minus 5x squared. At 2 points on the curve, the rate of change of y with respect to x is 4, which means the dy by dx value is equal to 4. We need to work out an equation in terms of x to represent the information, giving the answer in the form of ax squared plus bx plus c equals to 0, where a, b, and c are integers. So let's differentiate this equation. Dy by dx is going to be 3x squared minus 10x. Put this equal to 4. Then we bring the 3x squared minus 10x to the other side. So it's going to be negative 3x squared plus 10x minus 4 equals to 0. That is your equation as asked in the question. Then it says, hence work out the 2 possible values of x. Give the answers to 3 significant figures. So whenever it says hence, that means you're going to use your answer from part A in part B. So our equation was 0 equals to negative 3x squared plus 10x plus 4 equals to 0. So we just put this in the quadratic formula. X equals to negative 10 plus minus root of 10 squared minus 4 times negative 3 times 4 over 2 times negative 3. The reason why I'm using the quadratic formula is because it says give your answer correct to 3 significant figures. If it's saying it's going to be 3 significant figures, that means it's going to be a decimal. And for the decimal answer, you cannot use splitting the middle term. So it's easier to just directly go for the quadratic formula and save your time. So this gives us two values. We have 10 plus minus. The value of the root is going to be 12.165 over negative 6. So x is going to be 10 plus 12.165 over negative 6, which gives us 3.69. That's the first value. And the other is 10 minus 12.165 over negative 6, which is equal to negative 0.361. These are your values of x correct to 3 significant figures. Then it says for sequence A, the nth term is equal to n over 14 n plus 30. And for sequence B, the nth term is 2 over n. The kth term of sequence A equals to the kth term of sequence B. Work out the values of k. So sequences did come, I think, in paper 1 as far as I've heard. But they didn't give us limiting value or the quadratic sequence. So for the limiting value question, the quadratic sequence questions, once again, I would suggest looking at the video for prediction for paper 1. I added a question for that in that video. That's why I'm not including it this one, because then this video is going to be very long. So you can easily access those questions in that video. For this, I heard nth term did come, but I still wanted to do a difficult version of nth term because you never know, they might give it again. So it says that the nth term for sequence A is this, nth term for sequence B is this. The kth term is equal for both. So that means we replaced n with k in both the equations and put them equal to each other and then solve it for k. So that's going to be k over 14k plus 30 equals to 2 over k. Cross multiply. So k square equals to 2 times 14k plus 30. K square equals to 28k plus 60. Bring everything on one side. K square minus 28k minus 60 equals to 0. Once again, we have a quadratic equation, and you can solve this quadratic equation using splitting the middle term or the quadratic formula, whichever way is easy for you. I'm going to be splitting the middle term. So the quotient of k squared times 60 is 60. Factors of 60, which we can add or subtract to get 28, is 30 times 2. So we can replace negative 28k with negative 30k plus 2k, and everything else remains as it is. Split the equation into two groups, and then you can factorize them separately. In the first group, we have k common, so k minus 30 comes over here. Second group, we have 2 common, so again k minus 30 comes over here. K minus 30 is common between both k and plus 2. So k minus 30 times k plus 2 equals to 0, where one value of k is 30 and the other is negative 2. Your nth term cannot be a negative number, which means k equals to 30 is your final answer. For functions, I heard that inverse functions came, domain and range came. So based on that, what I did was I included a function on piecewise functions in this, and I included a question on composite functions. So for the piecewise function, it says that a function is given by f of x equals to 4x, where x is less than 0. Then f of x equals to x squared minus 8x, where x is between 0 and 8. And then f of x also equals to 16 minus 2x, where x is greater than 8. We have a sketch of y equals to f of x, as shown below. We need to work out all the values of x for which f of x equals to negative 12. So since we need to work out all of the values of x where the function equals to negative 12, that means we put all of these equations equal to 12 separately, find the value of x, and all of these values of x will be the answer for the question. So first we do 4x equals to negative 12, where x is going to equal to negative 3. Then we do x squared minus 8x equals to negative 12. Again, we have a quadratic equation because x squared minus 8x plus 12 equals to 0. Factorize it through quadratic equation or splitting the middle term. Either way, it's correct. It's going to be x squared minus 6x minus 2x plus 12 equals to 0. Between x squared and 6x, we have x common, so x minus 6 in the bracket. And between negative 2x and 12, we have negative 2 common. Again, x minus 6 in the bracket. So x minus 6 times x minus 2 equals to 0, where one value of x is 6 and the other is 2. Then for the third equation, we put 16 minus 2x equals to negative 12. 16 plus 12 equals to 2x. 28 equals to 2x. And 14 equals to x. So for the possible values of x, we have negative 3, then we have 2, then we have 6, and then we have 14. All of these are the possible values of x. Then for the equation of circle, we have the equation and they want us to identify the center and the radius. So you need to remember that the basic format of the equation of circle is x minus h whole square plus y minus k whole square equals to r square. Now you might be using something else instead of h and k, that's fine, but the basic format is still the same. The main goal behind writing this equation is to make sure that you know that it's always supposed to be minus in the bracket, not plus. So if in the case they gave us x plus something or y plus something, that means like, for example, over here it's x plus 7. So it's going to be negative 7 over here, not positive 7. And 4 will be positive. Why? Because the actual like format, the general form of the equation of circle is x minus h whole square plus y minus k whole square. So if anything is positive inside the bracket, you write it as negative in the coordinate. For the radius, we know we take the square root of this value. So root 36 is plus minus 6. But since the radius cannot be negative, we will use positive 6. Then for algebraic fractions, someone said algebraic fractions came, someone else said it didn't. I'm not sure, but algebraic fractions is a kind of topic which can get repeated in paper 1 and 2. So there's no harm in going through questions about it. If you look at the predicted paper version for paper 1, you will see that I posted a question in it where we had two quadratic equations or like a cubic or a quadratic equation being divided, I think. And you have to simplify it to like, factorize the numerator and denominator separately and then further simplify it. I would recommend checking out that question as well. And this one, I did not add a similar question because like I didn't want to repeat the type of question. I repeated topics, but not the type of questions. So in this, I used a question where we have fractions added with unlike denominators. And then I used another one where we had addition and division at the same time. So for the other one that I'm saying that, when you have to factorize the numerator and denominator, do check out paper 1 for that. So for this, what we'll do is you need to remember that when you're adding or subtracting fractions with unlike denominators, you need to make the denominator same first. So to make the denominator same in this case, we have 2x squared over here and 3x over here. So we can multiply the first fraction by 3 and the second fraction by 2x. When we do that, what we realize is that the denominator becomes 6x squared. So 21 over 6x squared plus 8x over 6x squared. So that's going to be 21 plus 8x over 6x squared. Since we cannot further factorize it because 21 and 8 don't come in the same times table. So this is your final answer, and that's why this is a 2-mark question as well. Like this one, this is a 5-mark question. It says simplify fully x over 2 plus 3x over 5 divided by square root of x to the power of 6 over 4. Now this might look weird, but honestly, it's not that hard. The bracket will be solved as we did in the previous question. We make the denominator same. So we times the first fraction by 5. So 5x over 10. The second fraction by 2. 6x over 10. Both the numerator and denominator will always be multiplied by the number, not just the denominator. Now for this fraction, it's square root of x to the power of 6 over 4. Now x to the power of 6 can be multiplied to the power of 1 over 2 because the root represents the power of 1 over 2. So if we replace the root with the power, so it's x to the power of 6 whole power 1 over 2 and then 4 whole power 1 over 2. Now square root of 4 we know is 2. So this becomes 2 over here. And in indices, when you have power outside the bracket and inside the bracket, we basically multiply those two. So it's going to be 6 times 1 over 2. Over here, we rewrite this as a single fraction. And we write 5x plus 6x in the numerator, which is 11x over 10 divided by 6 times 1 over 2 is 3. And this is 2. Now, when we're dividing fractions, what we do is we change the division into multiplication and take the reciprocal of the second fraction, which means it's going to be 2 over x cubed. We basically flip the second fraction. So when you flip the second fraction, you're swapping the numerator with the denominator. So now it's 22x over 10x cubed. We can simplify this. 22 and 10 come in the 2 times table, so it's going to be 11. X over x cubed gives us x squared over here. So 11 over 5x squared is your answer. Now, this question came in the 2024 paper 2. Obviously, they will not give the same thing, but something along the same lines can come in 2025 paper 2 as well. So we have square root of x cubed times the square root of x cubed plus x cubed divided by square root of x. The abundance of square root can make it look weird, but if you like break it down step by step, it's not that hard. So first we expand the bracket in the numerator. So it's going to be square root of x cubed being squared because we're multiplying the same thing. And then we have x cubed times square root of x cubed divided by square root of x. Now, when you take the square of a square root, the square root gets cancelled out. So this becomes x cubed. And if you remember, when we're multiplying similar bases, the base being x over here, and it's the same, we add the powers. So it's going to be x to the power of 3 plus 3 over 2. Because over here, the root represents a power of 2, as I said earlier. So 1 over 2 gets multiplied by 3, so it becomes 3 over 2. And this remains root x so far. So that's x cubed plus 3 plus 3 over 2 is going to be 9 over 2. And that's divided by root x. Now split this into separate fractions. X cubed over root x plus x to the power of 9 over 2 over root x. So whenever we have similar bases being divided, we subtract the power. It's the opposite of what we do when similar bases are being multiplied. So it's going to be 3 minus 1 over 2 plus x to the power of 9 over 2 minus 1 over 2. That's going to be x to the power of 5 over 2 because 3 times 2 is 6. 6 minus 1 is 5. 2 remains as it is. And this is going to be 9 minus 1 is 8. 8 divided by 2 is 4. And this matches with the format given the question as well, where they wanted the answer in terms of x to the power of a over b plus x to the power of c, where a, b, and c all are integers. Then I added another type of indices question which can come in the exam. You would have noticed that in this paper too, I added like for some questions, I added like, two types for each where needed because it's best to have maximum practice rather than, just counting on one type of question. So over here, work out the possible values of x. We have 2 to the power of x plus 3 whole power 4x plus 1 equals to 8 to the power of x minus 1. So for such type of questions, it's always advised to convert all the bases in the same number. Now, obviously, we cannot convert a smaller number into a bigger number, but we can definitely convert a bigger into a smaller number. That's much easier. We know that 8 comes in the 2 times table as well. So we can rewrite 8 as 2 cube. So that would be 2 to the power of x plus 3 whole power 4x plus 1 over here. And this becomes 2 cube whole power x minus 1. As I discussed previously, when you have a power outside the bracket and inside the bracket, we multiply those powers. So that's going to be 2 to the power of x plus 3 times 4x plus 1. And this is going to be 2 to the power of 3x minus 3. Now, when we have similar bases existing alone on each side of the equal to sign, we can remove the bases and put the powers equal to each other, which means x plus 3 times 4x plus 1 is equal to 3x minus 3. We can expand the bracket on the left-hand side. So that's 4x squared plus x plus 12x plus 3 equal to 3x minus 3. That's going to be 4x squared plus 13x plus 3 equal to 3x minus 3. Bring everything on one side. So 4x squared plus 13x minus 3x plus 3 plus 3 equals to 0. That's 4x squared plus 10x plus 6 equal to 0. Once again, we have a quadratic equation and we have to factorize this quadratic equation to find the values of x, which the question was asking us to do. So before we do that, I'm going to divide the entire equation by 2 because 4, 10, and 6 come in the 2 times table. So when we divide it by 2, so that's 2x squared plus 5x plus 3 equals to 0. Now let's factorize this. We know 2 times 3 is 6 and 2 plus 3 is also 5. So 2x squared plus 2x plus 3x plus 3 equals to 0. Between the first two terms, we have 2x common. So x plus 1 over here. Between the last two terms, we have 3 common. So again, x plus 1 over here. Between 2x and 3, we have x plus 1 common. So x plus 1 times 2x plus 3 equals to 0. One value of x is negative 1 and the other is negative 3 over 2. These are your answers. Then circle theorems. I don't think circle theorems came, so it will definitely come in paper 2. So for circle theorems, I looked at all of the past paper questions and honestly, this stood out to be the most odd one compared to the others. Others were quite simple. Like, you had to either use the concept of isosceles triangles or like, that theorem where angle at the center is twice the angle at the circumference or the cyclic quadrilateral one. They were actually like simpler to solve in my opinion. This one was like the most odd one, so I used this one for the practice. So if you notice, it says that A, B, C, D, and E are points in a circle centro. Work out the value of x. So for the value of x, we can see that we don't have a quadrilateral inside the circle. So we cannot use the cyclic quadrilateral properties. We have like this weird polygon, and since it says it's not drawn to scale, so we cannot say that the lengths are equal. It cannot be categorized as a regular polygon. So we need to break down the shape and see how we can solve it. We know that O is the center. So that means OA is equal to OB is equal to OD because all three represent the radius. So if this is 2x, that means this is also going to be 2x. So let's just first use this triangle to figure out what angle AOB is going to be. So angle ABO, as you can see, is 2x. So angle AOB is going to be 180 minus 2x, which is 180 minus 4x. Now, if you notice this angle, if this is 6x, that means this is going to be twice of 6x. So angle BOD reflex is going to be 6x times 2, which is 12x. Similarly, this angle is going to be twice of 7x. The same property, angle at the center is twice the angle at the circumference. So if this is the angle at the circumference, this is the center. So reflex angle AOD is 7x times 2, which is 14x. So keeping that in mind, we can say that this angle over here, that's going to be 360 minus 12x. So angle BOD, not reflex, is 360 minus 12x. And similarly, this one is going to be AOD, not reflex, 360 minus 14x. So, wait, this is different color. AOD. So, all of these add up to the blue angle, the yellow angle, and this green angle. Let me remove. So, if we add up the light blue angle, the dark blue angle, and the yellow angle, these three angles add up to 360 because it's a full circle. So, using this, we can create an equation to find the value of x. So it's going to be 360 equals to 360 minus 12x plus 360 minus 14x plus 180 minus 4x. We're adding AOB, BOD, and AOD, this, and this. So that's going to be, if we take 360 to the other side, it's going to be 360 minus 360 equals to 360 plus 180, that's 540. And negative 12x, negative 14x, negative 4x, that's going to be negative 30x. 0 equals to 540 minus 30x. 30x equals to 540. X equals to 18. So that is your value of x. Then ratio and coordinates. I don't think this came in paper 1, so I wanted to include this in paper 2. This was, I think, the most, confusing one out of the one that I saw in all of the papers. Obviously, they can give something else as well, but like this stood out the most to me, so I included this in the predicted one. So they've given us the line y equals to 3x plus 2. A and B are points on this line. And B, C, and point D, which is 5, 0, are points in the line L. OA is to AC is 1 is to 4. We need to work out the x coordinate of B. This is 5, 0. To work out the value of A, we can easily use the line y equals to 3x plus 2 because you can see that it lies on this line and the x value is going to be 0 because it's the y-intercept. So that means this is 2, 0. So that means A value is 2, so that's 0, 2 over here. We don't need to do any calculation for it. Then OA is to AC is 1 is to 4. So if OA is 2, AC is going to be 4 times of that. So that means this is going to be 2 times 4. which is 8. So 8 units above A is going to be 10. So 0, 10. So C has the coordinates of 0, 10. So now to figure out the value of B, what I would do is I would create an equation for the line L using the points C and D. And then we can simultaneously solve line L and y equals 3x plus 2 to find the x-coordinate of B. So gradient of CD is going to be 10 minus 0 over 0 minus 5, which is going to be 10 over negative 5, and that's negative 2. So we can use point slope form, y minus y1 equals to m times x minus x1, or we could even use y equals to mx plus c actually. Actually, let's use y equals to mx plus c. That's going to be more simple. Y equals to mx plus c. M is negative 2, so negative 2x. And c is your y-intercept, so it's going to be plus 10. So y equals to negative 2x plus 10 is the equation. And then we can simultaneously solve this with y equals to 3x plus 2, which is the other equation. So we put them equal to each other. 3x plus 2 equals to negative 2x plus 10. 3x plus 2x equals to 10 minus 2. 5x equals to 8. X equals to 8 over 5. So that is your answer for the x-coordinate of B. Then for differentiation, I use this question for tangent and normal, just in case they give it in paper too. So it says that P is the point on the curve y equals to ax cubed plus 10x squared, where x equals to 2. The gradient of the normal to the curve at P is negative 1 over 4. Work out the value for A. So they have highlighted normal, and there's a reason behind it. The reason is that whenever we have a curve and we have a tangent touching the curve, let's say, so your gradient of the curve is always equal to gradient of the tangent. So if you have the gradient of the curve, you can easily find the gradient of the tangent. But if we have a normal to the tangent, but if we have a normal to the curve, that means it's making a 90 degree. This line is making a 90 degree with the tangent. That means both are perpendicular. And if two lines are perpendicular, M1, gradient of line 1, times gradient of line 2 will always equal to negative 1. Hence, whatever is the gradient of the normal, which is negative 1 over 4 over here, so negative 1 over 4 times M2, which will be your gradient of the curve, equals to negative 1. So M2 equals to negative 1 times negative 4, and that's positive 4. This is your gradient of the curve, which is also going to be your dy by dx value, which we will use to find the value of A. So dy by dx for this equation is going to be 3a times x squared. You bring the power down and subtract 1 from the power. So 3 comes down and gets multiplied to ax. And the power of x becomes 3 minus 1, which is 2. Same over here, 2 times 10, 20, and x has a power of 1 now. So 4 equals to 3ax squared plus 20x. And they said that x equals to 2. So we can substitute this in this equation to figure out the value of A, because once we substitute it, A is the only unknown there. So 4 equals to 3a times 2 squared plus 20 times 2. That's going to be 4 equals to 12a plus 40. 4 minus 40 equals to 12a. Negative 36 equals to 12a. Negative 36 divided by 12, and that is negative 3. And that is negative 3. That is your value of A. Then for differentiation, I had to include a question about stationary points and the nature. This way you're covering both the second derivative and differentiation and stationary points in the same question without adding another question for that. So we have a curve with the equation y equals to x cubed minus 3x squared plus 5. We have to work out the stationary points of the curve and determine their nature. And we must show all the working. So let's begin with finding the first derivative. So dy by dx is going to be 3x squared minus 6x. The derivative of constant is always 0, so we don't write anything for 5. Now we put dy by dx equal to 0 because whenever the derivative is 0, that's where your stationary points are present. So if we have a curve like this, stationary points over here and here, these are your stationary points. And this is where your dy by dx is 0. So 0 equals to 3x squared minus 6x. Factorize it. We have 3x common. So x minus 2. So 3x equals to 0 and x minus 2 equals to 0, which means one value of x is 0 and the other is 2. Now we have to determine what is the nature of these points. And also it says stationary points, which means we need to find the corresponding y values as well. We need the full coordinate. So let's first find the y value. At x equals to 0, y is going to be 0 cubed minus 3 times 0 square plus 5, which is 5. And at x equals to 2, y is going to be 2 cubed minus 3 times 2 squared plus 5, which is y equals to 1, which means one coordinate is 0 and 5, and the other is 2 and 1. Now we have to determine the nature of these points. So we find the second derivative, which means we find the derivative of the first derivative. So that's going to be 6x minus 6. So now at x equals to 0, your second derivative is negative 6. It's less than 0, which means it's maximum. Whenever the second derivative is less than 0, it's a maximum point. If it's greater than 0, it's a minimum point. So which means this is a max point. And for the other one, at x equals to 2, d square y dx squared is 6 times 2 minus 6. That's 12 minus 6, that's positive 6. That's greater than 0. That's minimum. So this point is minimum. So that's your answer. Composite functions. This is something that did not come in paper 1 as far as I know. I heard domain and range came, inverse functions came, piecewise and composite did not come. So I still wanted to include composite functions in case it comes and someone doesn't know how to solve composite functions. So we have two functions, f of x equals to 3x squared plus 6 for all x, and g of x equals to square root of x minus 5 where x is greater than or equal to 5. We have to work out the value of g of f of 4. Now you will find a question for composite functions in the paper 1 predicted version as well. You can check out that one as well. You can learn from this one as well. Either way, whichever you understand better, just go through that. It's best for your practice. First, we find the value of f of 4 because f of 4 is your domain of g of x right now. So f of 4 is going to be 3 times 4 square plus 6, which is equal to 54. 4 square is 16, 16 times 3, and then plus 6. Then g of f of 4 is basically the same as g of 54. Why? Because f of 4 is equal to 54. So you can replace f of 4 54. So we find g of 54. So that's square root of 54 minus 5. That's root 49 is equal to plus minus 7. Now it says x is greater than or equal to 5, which means we use positive 7, not negative 7. Alternative method is that you first create the function of g of fx and then substitute the domain in that. So for example, G of fx means that anywhere there's x in g of x, it's being replaced by the function f of x. So g of fx, according to that, would be root of 3x squared plus 6. Instead of x, I'm writing f of x now because that is the domain of g of fx minus 5. So that becomes 3x squared plus 1. And then if x is 4, you just replace x with 4. And that gives you your answer, which is root of 49, and that's 7 as well. So you can solve it either way, whichever way you understand better, whichever method is less time consuming for you. Then show that f of gx can be written in the form of a times x minus a, where a is an integer. So we know that f of x is 3x squared plus 6. And g of x is root of x minus 5. So f of gx means we're substituting g of x in f of x now. The other way around. So now the x in f of x gets replaced by the function g of x. So as you notice, instead of x, I'm writing root of x minus 5, which is the value of gx. Square of a square root is the term inside the root, so that's 3 times x minus 5. Expand the bracket, so that's 3x minus 15 plus 6, which becomes 3x minus 9. We can take 3 common, so 3 times x minus 3. And as you can see, a is 3. So that's your answer. Then it says, show that 2n plus 3 whole cube plus n cube is divisible by 9 for all integer values of n. I don't think algebraic proofs came, so it's best to practice this question. Algebraic proofs is not that hard, honestly. You just need to simplify your equation and then, add or subtract the like terms depending on whatever is happening in the equation, and then see whether it meets the conditions that are being asked in the question or not. So keeping that in mind, I'm going to expand the 2n plus 3 cube. We can write it as a triple bracket, 2n plus 3 times 2n plus 3 times 2n plus 3, or if there's any other method that you've learned, please use that. There's no compulsion that you have to do it like this. So expand the first two brackets, I get 4n squared plus 6n plus 6n plus 9, bracket 2n plus 3 plus n cubed. So that's 4n squared plus 12n plus 9, bracket 2n plus 3 plus n cubed. Expand the bracket again. 4n squared times 2n is 8n cubed. 4n squared times 3 is 12n squared. 12n times 2n is 24n squared. 12n times 3 is 36n. 9 times 2n is 18n. 9 times 3 is 27, and plus n cubed. Collect the like terms. So 8n cubed plus n cubed is 9n cubed. 12n squared plus 24n squared is 36n squared. 36n plus 18n is going to be 54n, and then 27. As you can see, we can take 9 common. So we take 9 common, that's n cubed plus 4n squared plus 6n plus 3. So that means it is divisible by 9 for all integer values of n because 9 is common from the entire equation. So the solving part was very similar to what you've learned in algebra so far. It's just like the way you present your answer, you have to just show that it proves what the question is asking us to do. Three D trigonometry. So in 3D trigonometry, they can ask you to use sine rule, they can ask you to use cosine rule, they can ask you to use SOHCAHTOA, Pythagoras, anything. So for this, you need to remember all of your formulas and your rules when each is supposed to be applied. Like, for example, cosine rule is only applicable when you have all three lengths or when you have two lengths and the angle between them. That's when you can apply a cosine rule. Sine rule is applicable when you have one complete set of angle and length, the opposite length. Then SOHCAHTOA is applicable when it's a right angle triangle and they've given you an angle or a length, or you have two lengths and they want you to find an angle, something like that. Pythagoras is only applicable when it's a right angle triangle and two lengths are given. So you need to know these conditions very well in order for you to easily solve a 3D trigonometry question. So over here, we know that AB equals to 40 centimeters, BC is 9 centimeters, CG is 20. P is a point on HG such that HP is to PG is 3 is to 7. So 3 is to 7. So if you notice, AB is the same as EF is the same as HG. So HG is also 40 centimeters. AP is given as 25. We need to find the size of angle APC, which is like highlighted in the question. So first, using the HG length, which is also 40 centimeters, we can figure out what HP and PG are. HP is going to be 3/10 of 40, which is 12 centimeters. And PG is going to be 7/10 of 40, which is 28 centimeters. So this is 12, this is 28. So if you notice in the cuboid, the angles are 90 degrees, like the corner angles, which means this is 90 and this is a 90. So using these two right angle triangles, we can figure out the length of AC and PC. And once we have those, you will realize that we have all three lengths for this triangle. And if we have all three lengths, we can use the cosine rule. So using cosine rule, we can figure out the angle APC. So let's begin with finding the first length, which is AC. AC is going to be square root of 40 square plus 9 squared, which is going to be root of 1681, which is 41 centimeters. Then we find PC, which is root of 20 squared plus 28 squared, which is 1184 being square rooted, and that's 34.4 centimeters. So if you draw the triangle A, B, C, this is 25, this is 34.4, and this is 41. This is the angle we're trying to find. So cos of P equals to 25 squared plus 34.4 squared minus 41 squared over 2 times 25 times 34.4. Let's solve this to find the value of P. So cos of P is going to be 0.074046. We take cos inverse of this, which is going to give us 85.75, or you can round it to 85.8, correct, to one decimal place. Either way, that's going to be your answer. Then changing the subject, I don't think this came. I have one question in the paper one predicted paper as well. I have one in this, both are like slightly different. So I would recommend you going through that as well. It's just a 3-mark question. It doesn't take long to solve. So for this, we need to make W the subject and right now Y is the subject. So first step is to get rid of the square root on the fraction. So to get rid of the square root, we will square both sides. So when we square both sides, what happens is that this square root gets cancelled out. So it becomes y squared equals to x plus 2w over 3. Next is to cross multiply to get rid of the fraction. So it's 3y squared equals to x plus 2w. They want w to be the subject. So let's take x to the other side. It becomes 3y squared minus x equals to 2w. And the last step is going to be 3y squared minus x divided by 2. So that's your equation where w is the subject. Next is completing the square. Completing the square, once again, there's another question in the predicted paper 1 video. That one is also very similar to this one, actually, if I come to think about it. But if you want to try that one for practice as well, please do that. The more you practice, the better it is for you. So in this one, we have an equation which is 3x squared plus 2bx plus 8a. And that can be written in the form of 3 times x plus a whole square plus b plus 2. Work out the two possible pairs of values of a and b. So first step is to always make the coefficient of x squared 1. To make the coefficient of x squared 1, we're going to take 3 common from the entire equation. So that's going to be 3 bracket x squared plus 2b over 3x plus 8a over 3. As you can see, we take it common from the entire equation, not just from x squared. Now we have to complete the square, and the square that we're going to complete is going to be this. 8a over 3 is not a part of that square, it's separate. You must know that a complete square normally looks like c plus d whole square. Usually I use a plus b whole square, but since there's an a and b already in the equation, so I'm using a different variable. So c plus d whole square is the same as c square plus 2cd plus d square. This is the expanded version. We have the expanded version over here, which is c square plus 2cd. Our d square is missing. We need to figure out what that plus d square is going to be. Once we have that, we can convert it into c plus d whole square form and then simplify to find the value of a and b. So c square is x square, which means x is c. So that means 2bx over 3 is the same as 2xd. I replaced the c with x. So to find the value of d, because that's what we're trying to do, we do 2bx divided by 3 times 2x, which shows that b over 3 is our d value. So over here, we'll write 3 bracket x squared plus 2bx over 3, and we will add our d square. So plus b over 3 squared like it is over here, but minus b over 3 squared as well, plus 8a over 3. Let me write that in a different color. Plus 8a over 3. Separate that. The reason why I'm doing minus b over 3 whole square is because if you're adding something new in the equation, you have to subtract it as well. If you've seen the previous version for paper 1 prediction, you must have realized I explained that to you as well, that when you're adding something new in the equation, you subtract it as well. It's like when we're, making the denominator same in fractions. If you're multiplying something with the denominator, you have to multiply it with the numerator as well. So the same concept is applied over here. If I do plus b over 3 whole square, I do minus b over 3 whole square as well. So that's 3 times, now we can rewrite that as c plus d whole square. So that's x plus b over 3 whole square, because d is b over 3. And this is minus b squared over 9 plus 8a over 3. Now we multiply the 3 with the entire thing. So 3 bracket x plus b over 3 squared minus b square over 3, because 3 times b square over 9 is b square over 3, and 3 times 8 over 3 is 8a. Now, if we compare this with the equation in the question, a equals to b over 3 and minus b square over 3 plus 8a is equal to b plus 2. These are the two equations we have, which we will solve to figure out the value of a and b now. So 3a equals to b. Put in this equation, minus 3a whole squared over 3 plus 8a equals to 3a plus 2. Negative 9a squared divided by 3 is negative 3a squared plus 8a equals to 3a plus 2. 0 equals to 3a squared minus 5a plus 2. Now we solve this quadratic equation. That's going to be 0 equals to 3a squared minus 3a minus 2a plus 2. 3a common, so a minus 1. Minus 2 common, a minus 1 again. So a minus 1 bracket 3a minus 2. So a equals to 1 and 2 over 3. We put this over here, so b equals to 3 times 1, which is 3. And b equals to 3 times 2 over 3, that's 2. So these are the values of a and b. Then it says volume and surface area. So the radius of a sphere in centimeters is 3k over 2, and the volume of the sphere in centimeter cube is 972 pi. Volume of a sphere is 4 over 3 pi r cube, where r is the radius. We have to work out the value of k. So we have the volume, which is 972 pi equals to 4 over 3 pi. Radius is given as 3k over 2, and then we cube it. So 972 pi times 3 cross multiply divided by 4 pi equals to 3 cube 27, k cube, and 2 cube is 8. Take everything to the other side and isolate k cube. So the pi's get cancelled out. We have 972 times 3 times 8 over 4 times 27 equals to k cube. That gives us 216 equals to k cube. Take the cube root on both sides. K will equal to 6. So that is your value of k. Now for differentiation, I think like for the trapezium question, it was a maximum and minimum one. I think I might be incorrect as well. Please let me know in the comments if I'm right. If a question on the maximum minimum value of the area for trapezium came, because I know that it was either it was an inequality one, I don't know, I might be confusing it. But like what I remember, like either it was an inequality one or it was a maximum and minimum one. Once again, to be on the safe side, I chose this volume one where they give us a cuboid and they're asking us to create an equation for y, then we need to find the volume, then we need to derivate it, and then find the maximum value. So this question has basically a good revision for, this question is basically a good revision for differentiation. So there's no harm in once again solving this. So it says that the total length of all edges is 300 centimeters. So we have to show that y equals 75 minus 6x over 2. If this is 3x, that means this is 3x, this is 3x, this length is also 3x. Similarly, this is 2x, this is 2x, 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 and all of these are x plus 2y. So using this concept and that the perimeter is 300, we create an equation and then make y the subject and show that y equals to 75 minus 6x over 2. So 300 equals to 4 times 3x plus 4 times 2x plus 4 times x plus 2y. I'm going to take 4 common from the entire equation. So that's 3x plus 2x plus x plus 2y in the bracket. 300 divided by 4 equals to 6x plus 2y. That is 75. Then we subtract 75 and 6x. So 75 minus 6x equals to 2y. And 75 minus 6x over 2 is the value of y. So that is exactly the same as what is given in the question. Then it says the volume of the cuboid is V centimeter cube. So that V is 450 x square minus 30 x cube. So volume is basically going to be 3x times 2x times x plus 2y. We will replace the y with the equation that we created for it. So 6x squared times x plus 2 bracket 75 minus 6x over 2. So that's 6x squared bracket x plus 75 minus 6x. That's 6x squared times 75 minus 5x. 6 times 75 is going to be 450x squared. 6 times 5 is 30x cubed. Exactly the same as what's given the question. Then use calculus to work out the maximum value of V as x varies. So the maximum value of V, we find dV by dx. So that's going to be 900x minus 90x squared. Put dV over dx as 0. So 0 equals to 900x minus 90x squared. Take 90x common. So that's 10 minus x. 90x equals to 0, so x is 0. And 10 minus x is 0, so x is 10. So for the maximum value of V, we put these back into the volume equation. To figure out which one is the maximum value of x, we first find the second derivative. So d squared V dx squared, that's going to be 900 minus 180x. So we can clearly see that at x equals to 10, we're going to get a negative value. 900 minus 180 times 10, that's negative 900. Since d squared over dx squared is less than 0, this is the maximum value. So we have to work out the maximum value of v. We will put x equals to 10 into the volume equation. So that's v equals to 450 times 10 squared minus 30 times 10 cube. That's going to give us 15,000 centimeter cube. That is your maximum value of V. Then I wanted to include a question on exponential graph because I don't think that came. I think they gave a question on Cupid graph. Sketch of the curve y equals to a times b to the power of negative x, where a and b are positive constants. We have the point 0, 3, and 2, 0.48 that lie on the curve. You need to figure out the values of a and b. So very simple. You just substitute the value of x and y in the equation, create two equations, and use those to find the values of a and b. So firstly, we have y equals to a times b to the power of negative x. So when y is 3, x is 0, so 3 equals to a. You already have the value of a. Then when y is 0.48, a is 3, B is B, and to the power of -2. So 0.48 equals to 3 over B square, because B to the power of -2 is the same as 1 over B square. Cross multiply and bring 0.48 in the denominator over here. So this way B square is the subject. So B is root of 3 over 0.48. That gives B as plus minus 2.5. But I think the question said that they're positive, yeah. So which means your B value is going to be positive 2.5, not negative. So that's 2.5. And with that, I think we are done with the questions. If you have any questions or confusions regarding any of these, please leave a comment below and I'll help you out. And if you think I've missed out any topic, that I've repeated something that already came in paper 1 and I should have used some other topic instead of that, please leave a comment below and let me know as soon as possible so that I can create a video for those questions before the exam on 18.